All right, now we're good to go. Okay, I put all this in here. I just copy and pasted all this stuff, and what do we have going on? Well, we've defined our class, we made a constructor, and you'll notice that I put these underscores in front of all the attributes. That means they're private. That means that we have access to these like variables, these attributes, within the class, but I'm not really supposed to access them outside the class. We have a couple of extra methods here. And then we had this repr one, which is a special one, right? We don't actually call repr by saying the object dot underscore underscore repr underscore underscore parentheses. We don't do it that way. We just say print, and then it just calls it automatically. Similarly with the EQ, this is the one where we get to define what it means for two enthusiastic students to be equivalent. And in my case, I said, well, make it when their student numbers are the same, they must therefore be the same person. I could make it whatever I want, but that's what I decided to do. And again, I would never want to call this function by saying student A dot underscore underscore EQ underscore underscore student B. No, you wouldn't do that. You'd say student A equals equals student B. And now that equals equals, like you've used every other place to ask about equality, will automatically go and run the EQ method for you. And then we added these two other ones here. Get first name, get student number. I could have said get last name as well. I could have said setters as well and whatnot. But if we go here, so I talked about public-private. Now we have these getters and setters, which is going to seem rather silly, especially at this stage. But hopefully as time goes on, it'll click a little bit more as to why we like them. If we set the attributes to the object we're writing as private, that means that within the code, within the class, enthusiastic student, I have access to all of those private attributes. It doesn't matter. They're in the same class. But as soon as, just one sec, as soon as I am coding and I'm making enthusiastic student objects somewhere else, not within the class, I'm not supposed to access those private attributes. It's like, no, don't touch them, leave them alone. They don't belong to you. They belong to the object, and the object's in charge of that. Yeah?
So last class you mentioned that two underscores makes something extra private, but you didn't explain the difference.
Let's not worry about that, because it's more than just making it extra private. There's some actual like extra fancy stuff in it, but that's very Python specific, so not overly important right now. Interesting question nonetheless, but we'll not worry about that one. So it's private. We can still access it in Python. You can still access the things that start with the underscore. You can. But you're not supposed to. In other programming languages, if you specify it's private, it won't let you. It'll just say like, no, there's no variable called that, even though you're like, but it's right there. Yeah, it's private. You don't have access to it. But if you make your attributes private, then, and you really do want to have access to those values, okay, fine. But you have to write getters and setters then. A getter and a setter. Get information from the object, and then set information to the object. What they will look like will depend on what you want them to do. If you end up just making your attributes private and then make a getter and a setter for them, it does seem a little silly. But maybe I have first name, last name, student number, and current average. Maybe I would make it so I don't want it that, like, no one should be able to access the current average. It's used in the class for whatever reason, but no one gets to access current average from outside the class. Because it's, they're not supposed to see it. So I don't write a getter for current average, but I might write one for first name, last name, and student number. But current average, I leave it alone. I could, I guess, make a setter for first name and setter for last name, change their first and last name, but maybe I don't want to write a setter for student number because student number shouldn't change. Once it's created, leave it alone. Don't touch it. Don't change it. So you can write a getter for student number, but you don't write a setter because it's not supposed to be changed. And you don't want to allow someone to accidentally make a change that they shouldn't be doing. It's like a safety barrier. And then there's more to it. Like if you said set first name to the integer 17. Well, in our setter, we could say if it's a string that only contains letters, okay, fine. Otherwise, don't change it. Leave it alone. So the setter can add extra protection. A fun example some students came up with yesterday in the lab was, for whatever reason they decided, and I wouldn't do it this way, but for whatever reason they decided they wanted to make another attribute called full name. So, nope. There. They did this. But the problem was, every time they would do like set first name, it would change the first name, but it would never update the full name. So I'm going to go write a set first name. And this would be the similar for the last name and whatnot. So I would say self there. So this is how I would call this method if I wanted to update the first name. But the trouble here is the full name attribute's not getting updated. So what I could do is, okay, well, if you want to update the first name, that's great. But as a consequence of doing that, we need to have this like extra thing done to say, okay, well, nope. If we ever set the first name, great, but we'll also make sure to secretly, on the back end, update the full name as well. So the setters can do more than just set things, and the getters as well. They are the gatekeepers. You might say, well, what's the point of making a gatekeeper when I'm just going to go in and out all the time? I know what you're asking, but in general, you'll do it in such a way that you'll have these rules. So you write these getters and setters for having better control over how people are interacting with the data within your classes. I know it sounds silly at this stage because you're just getting used to it, but as you go, it should become a little clearer. Do we have any questions about this? Because it is a funny idea. I get it. Everyone's okay with it? Okay. All right. So here is an example. We don't have to do this one here together, but here's an example. Enthusiastic student, A student, Bob Ross, 007. Great. But I'm now changing student number to 5, just the number 5. That code will work. But I see that it starts with an underscore, which means I'm not really supposed to be doing this. And on top of it, from the looks of it, maybe student numbers are supposed to always just have 3 numbers. They have to be 3 digits long. But here I was able to change it to a 5 and it'll do it. But if I did it with a setter, I can check. I can check that, oh, okay, it's got to be 3 digits long. Further, you'll also see that in the example above, when we set the student number to 007, it's actually the string. Here I changed it to the integer 5. So it's even more of a problem. So by accessing these attributes not through these getters and setters, we could easily introduce messed up data that will just ruin everything. So we like those things as the gatekeepers. Any questions about this enthusiastic student stuff? Because we're going to move on to a much bigger idea right now. So ask the questions now before it gets even crazier. So we're all okay with objects. All right, great. I've got this very simple little object. It's got a couple of methods, and it stores some information about students. There's nothing crazy going on. And I would say this is a simple object. Not trivial, but it's simpler in that there's not a lot of crazy stuff going on. But you know what? It's going to be really hard if I've got like a whole bunch of these student objects just floating around. What I want to do now is make another class called My Students. That will basically be like a container class for enthusiastic student objects. So I want this class to be the thing that keeps track of my students. Okay? So I'm going to do this by basically just making a class that is basically a list, but it'll keep track of other things for me. And it'll help me interact with the enthusiastic student object and how I can add and remove them from classes or something. Do you have a question? No? Okay.
My ears feel a bit sore right now, so.
All right. So I'm going to start with this. Oh. So go here. We're starting another class. So what do we have? We say class, my students, and then we've got our constructor. And our constructor only takes one attribute. Then it's got a default value, great. And the one attribute it takes is name, which is going to be, or takes one parameter, pardon me. Takes one parameter, and it'll save it to an attribute called like class name. So that would be like CSCI161 or something, or Introduction to Programming, whatever you want to call it. And then I also create another attribute. Now, you'll notice that the second attribute, list of students, there's nothing about it in the parameter list. There's no parameter for it. It just starts as an empty list, which makes sense. If I create a class object, or a my students object, it should start as empty, right? There's nothing in there. Kind of like a list. When you start it and you create it, well, there's nothing there. You have to start adding stuff to it. So I just start by saying list of students, empty list. Because remember, everything in the constructor is run, and that's where all like the setup code does. So it's like, okay, I want a my students object. Okay, I'm going to prepare. Your code will say like, okay, I'm going to prepare this object for you, and one of the things in it is an empty list that I can do stuff with later. It just sets it all up for us. So, yeah, and the reason I emphasize this is a lot of people get confused because they're like, well, there's no parameter here. How do I know I need this as an attribute? You're thinking too hard. You can do whatever the hell you want. You could have a parameter for it. You don't have to. You do whatever. So we will write this method here. And I'm going to fix this indentation. There we go. So I'm writing a method called addStudent that takes I was being lazy here with my parameter names. First name, last name, student number, and average. And this method just does two things. First, it creates an enthusiastic student object based on the data passed to this method. Then it takes that student object and appends it to, I guess really it takes the reference to it and appends it to the list of students. That's it. That's all I'm doing. It takes the information I need to create a student, it creates the student, it adds it to the list. That's all. It is like you'll see here, I made it such that addStudent takes the first name, last name, student number, and average. I could have made it that it takes an enthusiastic student object that I simply just append. Both would work fine, but here I decided to do it this way. And now here's one. Nope, there. I check to see if a student with a given name, which is probably a bad way to do it, considering The thing I really cared about for comparing students was what value? Student number. I heard someone mumble it. But here I'm comparing first names. So perhaps a bad design decision, but whatever. I can do whatever I want. So here I say find student. And what it's doing is, well, it's just going to tell me if that student with that name exists within the class. Is there a student with this first name in the class? That's it. And all it does is a linear search. For each student in the list, check if this name is equal to this student's get first name. If they're the same, well, then it's in there. If not, keep going until you find it. Or if you get to the end, it's not there. And of course, we should probably put our repr. Remember, we like repr. Because we want to have a reasonable, here, I'm just going to take all this. Come on. A reasonable string representation of our object. Now, what would make sense? We get to do whatever we want. But what's kind of neat here is I wrote a repr for enthusiastic student, right? It just prints out all those details about the student. Let's have a look. Right here. It says first name, new line, last name, and then student number and current average. It prints out all that information. Great. So that's one student being printed out. But in the My Students class, I'll have a list of enthusiastic student objects. So what do you think would be a reasonable repr for enthusiastic student? I mean, we got the example right here. Here's what I did. Is I start by saying, okay, print out or take a string and set it to the name of the class, the attribute here. So like CSCI161, new line. Then for each student in the list of students, turn that student into a string. How does it know how to turn the student into a string? Any ideas? No? No ideas, huh? Even though I just said it 5 minutes ago? Well, we get the string version of the student, and then add new lines. And do that for each student. And then when we're done, we return the string. Remember, repr never, ever, ever prints out the string. It returns the string. Then you can do whatever the hell you want with it, like print it out. No one has any idea how it knows how to convert the student to a string. Well, yeah, but that's me saying, okay, student, become a string. But how, I can't just make a class and say, okay, turn this into a string. What does that mean? I'm not going to lie, this is a little concerning. It's the repr. We tell it, okay, you want to turn it into a string? Well, that automatically calls this magic method right here, repr. So the My Students repr makes use of the students object repr in it, which is pretty cool. So it basically says, turn this object to a string. I don't care how you do it, just do it. I wrote how we did it in the enthusiastic student class. But as long as there's a repr in the class, I can tell it to convert to a string, and it'll do it. However it's told to do it, which is pretty cool. So this will take each individual student, add its details based on the enthusiastic student's repr, append new lines to that string, and carry on. Yeah?
Why do you need to turn the student
Well, this will call the repr. So when I say stir of this automatically goes and runs the repr. Because otherwise, and then the repr says, okay, here's how to turn yourself into a string. If I just did this, well, student is a reference to a student object. So we're saying, okay, we don't want the student object. I want the string version of that. So it goes and calls the repr. And it calls the repr belonging to the class. Well, this is of type enthusiastic student, so it goes and calls the enthusiastic students repr. Other questions? Yeah.
How does Python know when we write out a wrapper that we're giving it permission to like take the string and or to turn the object into a string or to print it in? Like, is it by the name that we're using underscore?
Yeah. So underscore repr always has to be the string one. Underscore EQ, it means that whenever you call EQ, like the equals, it calls that. If you accidentally called it underscore EQ underscore, but not two underscores, it wouldn't work. It would say, I don't know what that is. And it would, in fact, if you did that, it would say, here, let me show you real quick here. Run, okay. And then we'll run this. I'm going to create a my students class, or object, pardon me. Oh, wait, no, you get one by default. Okay, here. My students, whatever, it'll have default name, C1, C2. So C1, C2. I hit run, they'll exist. It'll go build it based on the class, how it's described. If I come here and say print the length of C1, it's going to say, well, there's no such thing as length. There's no length. I can't, that's not a thing. Also, if I try to say C1 at index 0, it'll say like, well, it's not subscriptable. But maybe I want, like, look, my students is basically just like a list with some extra crap wrapped around it. So maybe I should be able to index it like a list. Maybe I should be able to get the length of it. Seems reasonable. Why can't I? But I tried to run it and it wouldn't work. So there's other magic methods that I could use. Oh, do I not? Where the heck do I talk about them? Is it in the lab maybe?
I couldn't see them until afterwards. I was looking for them earlier. Couldn't find where they were.
Maybe they were in the lab. Let's go have a look. Lab 11? Okay, lab 10. There. More special functions. There's one, underscore, len, underscore. That will get called if I ever ask an object what its length is. So let's do that real quick. I'm going to add this to my students class. It's not going to take any parameters other than the required self thing. And then return. Well, here it's kind of easy. I'm just going to hijack the list's length. Because the list's length is going to be the length of me, like the my students object. So I will just propagate it down to the, come on, list of students. Great. So now I'm going to run this. Now it says 0. Before it said there's no length. I don't know what that is. But because I added underscore len, now it knows that if I ever see someone trying to ask the length of this thing, it's going to go and look for the magic method underscore len. If it exists, it'll run it. If not, it's going to say, well, I don't know what that is, like it did a moment ago. Now it does. There's another one here too that I show, get item. This is the one that you define if you want to be able to index your object like a list. This one will take a parameter, I. This will be the index you want. And well, because I'm just basically hijacking a list, I'll just access the list. I'll just index the list. List of students at index I. Want to take a wild guess what the name of the method is? Sorry, at no point about what you should be doing is guess it. What is the name of the function within the list class that this right here is inevitably making use of? Get item, but it's the list's get item. And you're like, but you're not calling the get item. Well, no, I'm not, but I am. Because when I index it, it goes and looks for the underscore underscore get item underscore underscore. Yeah.
How do they make the get item?
How did they make it? I don't know, go open up and look at the class. So I'm going to tell you something. In Python, lists are already a very, very high level object. Next semester, we'll learn a little bit about arrays. And the arrays are, I'm conflicted because this is a really fun thing to discuss, but we don't have time right now. But it's based on, indexing is based on basically memory addresses and whatnot. So if I say, if my array starts at memory address X, and I want the thing in index 0 of it, I would say, okay, memory address X plus 0. And then what's there? Plus 1 is what's next. So the indexing is kind of just a fancier or an easier convention of doing like memory arithmetic. But we'll have fun with this next semester. So stay tuned. So I'm going to run this. I'm going to run this. Oh, that's the length one. Well, the problem is I don't have any students. So C1 dot add student A, B, C, D. And I'm going to do this a bunch of times. Now if I say, okay, print len of C1, print C1 at index 3, we see 5 and then A, B, C, D. Because now I can actually index the object because I wrote the magic method find item. There are a lot of these methods. Abs. Want to take a wild guess what that might have something to do with? Absolute value. Because you know how you can ask like abs of -7 and it'll just 7. Well, what if what you're doing, you want to be able to do that? You want to be able to say abs of your object. Doesn't make sense in our current case. It's rather silly, but we could do it. So if we ask the absolute value of our object, it would return something. Again, it's not going to directly call the method, like you wouldn't type my object dot underscore underscore abs underscore underscore parentheses. You wouldn't write that. You would say abs of your object. That automatically goes and calls that magic method. There's add. What do you think this will do? Yeah, go figure. Addition. What does it mean for two of your objects to be added together? Remember how like with lists? Well, lists add means concatenate. Integer adds mean, well, integer addition. We could go and run add We can go, here, let's do it. Exactly, that's the attitude we need. So, I have C1 and C2. Let's take C2 will be W, X, Y, Z. Shoot. Why didn't you tell me just a moment before you did?
I was thinking it, but I'm like,
Maybe he knows what he's doing. No, I do. Okay, great.
that's basically what happened.
So here we go. I run that. Now if I say C1 plus C2, it's going to say, what the hell does this mean? Unsupported operand for plus, my students and my students object. You can't add them together because Python goes, what the hell does that mean? Until you come along and say, well, here's what it means. You will say, and here we'll just make use of the lists. We will, how about this? We will combine the lists of students. Oh crap, this is going to get complicated. For the sake of not making this overly complex and kind of getting lost in what the details that aren't that important, add will simply make use of the lists add. Because why not? But remember, I can put whatever the hell code I want in here. I'm going to show you an example of something ridiculous. Return 77. Whenever I add two my students together, it'll give me back the number 77. Hopefully. 77. Why? Because that's what I said. If anyone ever tries to add two of my student objects together, it gives you back 77. Now that's rather ridiculous, so doesn't really make sense here, but I could do it because the point is when I call plus, it automatically goes and calls the method underscore underscore add underscore underscore. That's why. Exactly. But just because you can doesn't mean you should, right? Because it is a rather ridiculous idea, right? Oh, add these two my students together, 77, right? But we could. Because that's what gets called. Yeah?
So for the final exam, would it be more common magic methods that you would?
If I ask you to write any magic method on anything to do with the exam, it wouldn't be anything beyond like repr and EQ or anything. This is the first time I've ever actually used underscore underscore add in Python in my entire life. To just put you can do it. It's cool. I mean, I'm not a Python programmer. I'm sure a lot of Python programmers do this a lot, but I don't know. This isn't something that's like, oh, you got to make sure you memorize your Python magic methods. No one would do that. Yeah. What language? I'll use whatever language, depending on the circumstances. A lot of times these days it will be Python, but as you'll go learning more and more computer science, there's there is your fundamental programming, and then there's the programming, but then making use of special features of the given language that kind of gives you some extra benefits. So this is one of those of Python. I'm a really lazy programmer and keep it very basic and vanilla because I want my algorithms to be transferable, for lack of a better term. So I don't make it overly Python-y, right? It's oh yeah, you're learning Python in this class. Not really, because I haven't actually really showed you anything Python-y. There's some of it that I'm showing you, like these magic methods. But there's if you're a Python programmer, that means a hell of a lot more than just writing code that runs with Python. And if that weirded you out, don't worry about it. This will make sense later. Okay, and. What do you think and is for? This one's a tricky one. When you and two of these objects together. Yeah. So what do you get back if you call and C1 and C2? I mean, that doesn't really make sense in this case, but we could do it. Bool, turn it to Boolean seal. This is the sealing class. Del atter, dir, div mod, doc, EQ, float, floor div, format, GE. Who wants to take a wild guess on this one? I'm not 100% sure, but I'm pretty damn sure I know what this one is. Let's try it? Yeah, but we have to write it. right? So if I write it, I'm going to want to know what the convention is. Did you Google it?
Google it.
Fine. Did you Google it? All right. Well, if you do Google it, I have a strong suspicion it's greater than or equal to. So if you use greater than or equal to, this tells you what to do with it. It is? There you go. What about GT? What do you think GT is? Greater than. Hash. Don't worry about this one. I'm looking at you. Index. If on your assignment 4, you see something that says like, uh-oh, I don't know how to hash this, back up. Because you've gone down a hole that's probably a smart idea, but you haven't learned enough to do it the right way. So if you ever see this error of like non-hashable, you didn't write hash, back up. Yeah, just turn around and back it up. Don't get as fancy as you are. Index, init, L shift, LE. Exactly. Or there's a whole bunch here. Cool. Any? Any? Oh, I was looking for any, A-N-Y. Any, probably not equal, I'm guessing. Yeah, I was like, any. I have no idea what any is, but N-E, okay. All right, cool. So there are a bunch of these magic methods. Realistically, the ones you'll use, well, like if you're in 162, we'll be using Java this year. And in Java, the equivalent, I guess, for lack of a better term, the only two that you're going to really be working with would be the EQ and the repr. But in Java, it's not called underscore underscore repr underscore underscore. It's called toString. In Java, your EQ is equals. So you've got them as well. Now there are other ones too, like hash and all that, but we're not going to talk about those. But your string and your equals are probably the most common ones that we'll care about right now. So yeah. So if you're thinking, oh man, the magic methods, no. They're there because they're cool and you can do this and you do whatever you want with them. If you don't want to use them, don't. Doesn't matter. Unless I tell you to, then do it. Any questions about any of that, though? I want to make sure I'm emphasizing the point of what's important here is the objects and how I created the simple one of the enthusiastic student that had a couple of silly little methods and a couple of attributes. And I also had the other object that was kind of like this bigger one that stored instances of other objects. And I could keep going. I mean, then we could have another object that deals with these other ones. So like on your assignment, who here started assignment 4? Nerds.
I started.
You started it. Okay, you only started. All right. So all you have to do with that is you'll have, like, the analogy here, the analog would be your country object would be similar to the enthusiastic student. Your country catalog or whatever it's called will be similar to the my students. One is an individual thing that's kind of holding on to information. The other one is a collection of those things. Okay. Any last questions about those objects or anything? Yes?
How would you actually be able to like concatenate two first names with that? I tried to do it.
With the add, concatenate two first names?
Yeah, just like add.
Well, so add probably makes a little bit more sense for the enthusiastic student objects, not the my students. But yeah, let's do it. You want to add two students together? Yeah, all right. So first, okay, ASD equals enthusiastic student, and then we'll do the same thing. There. And then if I go, I try to add these students together, I can't do that. Well, let's make it. So, def How about this? Return first name plus get first name. Sure. Oh, colon. Now if I go down here and run it, we see John John. Because that's what add told us to do. Not this one. This one. The one for the enthusiastic student class. Other questions? Yeah.
Why when you wrote the code for the add function, did you use just dot first name for self and then get first name for the other?
Because self first name is my attribute, so I have access to it. Now, for the other, that is another student object. And because it's a private attribute, I'm not supposed to access it, although you totally could if they're of the same class. I'm just going to use the accessor method. In fact, I could do that here too. Get first name. It'll still work. Yeah. And I saw a hand over here. Was it you? No, or were you just yawning again? All right, what time we got? All right, I'm going to be really nice and let you leave 2 minutes early. 1 minute early. You're right.